Good morning, guys. So in this video, we'll be seeing what is dynamic routing. So last video we saw what is static routing, and then we also configured a floating static route. So this is a completely different routing. So as I already informed, there are two types of routing. One is static routing, and the other is dynamic routing. So static routing is normally for small networks, and then dynamic routing is for big networks. Okay, networks that cannot be manually configured can be using dynamic routing. So in the static routing, we actually configured every network that is not directly connected to the router. But in dynamic routing, we'll be configuring the networks directly connected, and it will be informed from the routers to the other routers. That is called as dynamic routing. Okay, now the routers are going to inform about these networks, okay, about this 1.0, 2.0 and the other networks which is directly connected to the other routers through a special message. Okay, so from R1 to R2 and R1 to R3. Similarly, the R2 router will inform about all the known networks to either R1 as well as R3. Similarly, R3 will inform to R2 and R1. And after getting these messages, the routers will update their routing table. Now that is how the dynamic routing protocol actually works. Okay, so we are going to configure one by one the routers R1, R2 and R3, and then I'm going to walk you through the set of commands that are going to be used in dynamic routing. So let's start. So first is we have to configure. Now you have two parts in this static routing, and make sure that you note this number. It is 3.2.1.8. it is configuring of RIP version 2. Configuring RIP version 2 is 3.2.1.8. right. So what is the we have many dynamic protocols in practice. Now the protocol that we are going to study is RIP, which is called as routing information protocol. Okay, now you would have studied this in your theoretical classes also. Now RIP is called as routing information protocol, uses a concept called as distance vector routing, DVR. Okay, we are not going to delve into the details here of how RIP updates this table and all. We're just going to see the practical aspect of it, how the router updates this table automatically. Okay, so RIP is routing information protocol, DVR is distance vector routing, and we are going to go through the set of commands for this RIP protocol. Now this is the only dynamic protocol that we are going to study for this module 2 syllabus. Okay, right. Now first step 1 is to configure the RIP version 2 on R1. Okay, so we are going to configure on router R1 first, and then we will go to R2 and then to R3. Now first use the appropriate command to create a default route on R1 for all internet traffic to exit the network through S0/0/1. Now this is actually a static routing command. We have already done this in static routing also, creating a default route for the router. Now if you can remember, default routes are routes which are used if none other IP matches with the incoming packet, so the packet will take the default route. So that is the default route that we have to configure. So how to configure it in R1? So we'll click on R1, we'll click on the CLI tab. Okay, enter the privileged execution mode, so enable, and then enter the configuration mode, so configuration terminal. Right. So first is we have to configure the default route. So the command is IP route. The default route is 0.0.0.0. Subnet mask again 0.0.0.0. Okay, and he has said to use the exit interface S0/0/1. Okay, so he has said clearly this exit interface is 0/0/1. That is the interface. So we'll check what is this exit interface in the topology. So see here. Now router R1 has actually three interfaces. So one is this one, other one is this one, other one is this one. Okay, and you can see actually the internet is connected to the this interface. Okay, so most probably default routers are normally used when we use the default router to get through the internet. Okay, so this S0/0/1 must most probably be this interface. Okay, shall we check it in the topology itself? So I'll keep the mouse over here. It should actually show the exit interface. Yes, it is showing. It is serial 0/0/1. So what we thought was right. So we'll configure that here. So it is space serial 0/0/1. Enter. Okay. Now the warning will be given, so it doesn't matter. So we have configured the default route. right? Next, enter the RIP protocol configuration model. This is the starting point of RIP. So the command to enter the RIP mode is router RIP. Okay, note that it is router RIP. Enter. Now you can see that the config is changed to config router. Okay, so that's mean we have entered into the RIP mode, right? So in the RIP mode we have a set of commands that are not available in the normal config mode, so which is exclusively available for the RIP mode. Use version 2 of RIP protocol and disable the auto summarization of networks. Okay, so I need to explain this. Actually, when RIP was first found out, there was the version 1. It was actually supporting only the classless addressing. Okay, sorry, classful addressing. You know the difference between classless and classful addressing. Classful addressing will have boundaries, okay, at 8, 16 and 24. Okay, if you can remember clearly, there are class A, class B, class C. Okay, and each class will have subnet masks such as /8, /16 and /24, and the version 1 supported only classful addressing. So the version 2 of the RIP protocol supported classless addressing. Okay, so classless addressing, okay, there is no specific boundary. We can actually have subnet masks differing from this /8, /16 and /24. We can have many different subnet masks. And so if I'm going to enable this version 2 of RIP protocol, I have to enter the command which is version 2. That's it. You don't have to enter any other thing, version 2. So we have entered version 2 of the RIP mode. Okay, and there is one other thing in this particular question, that is disable the auto summarization of network. So auto summarization was in effect when we have classful addressing. Okay, actually, for example, if I have slash 10 or 12, for example /27, if it is /27, this will be automatically summarized in my routing table as /24 because the classful addressing are at /24. Okay, so whatever the addresses or whatever the masks that are greater than /24 will be automatically summarized to /24. That is what auto summarization means. Now this is not an actually per se a problem, but it will be difficult to understand the routing table. So we can actually disable the auto summarization feature in this version 2 of the RIP protocol. Now a simple command is disable auto summary. Okay, so I think we have a problem. Okay, so it is not disable auto summary, it is no auto summary. Okay, if you have any doubts what are the commands that are available, you can just put a question mark here. Okay, and what are the available commands in this router RIP will be automatically shown, and you can see that the simple command is auto summary. So if I simply put auto summary, auto summarization will be come into effect. If I put no auto summary, no before the auto summary, it will be cancelled off. So that is how the commands work, right? So we have completed point number 3 here, and then we are going to now configure RIP for networks that connected to R1. Now this is the point where we advance to the next level. I have enabled the RIP mode, which is by router RIP command. I have entered the version 2 and I have disabled the auto summarization feature. Now I'm going to do the configuration. So the configuration is, what you have to do is you have to configure the networks that are directly connected to R1. Okay, so you can see here this is in direct contrast to your static routing. So in static routing we did not configure the directly connected roads because we know that the networks that are directly connected. The router should know the networks that are remotely connected. So we actually configured the remote networks. We entered the remote network path. Okay, now how to reach this network through either the next interface or your exit interface. Okay, or your exit interface. This is how we configured in the static routing. But in dynamic routing, what you have to do is we have to mention the directly connected networks. Okay, we have to connect the directly connected networks, and we don't have to mention anything here. Okay, because they are directly connected. They are directly connected to the router, so there is no exit interface or your next hop interface. So just your directly connected network mentioned here will suffice. Okay, so we'll see how that works. What we have to do is we have to see what are the directly connected networks first to router R1. So router R1 is directly connected to network 192.168.1.0 and then 2.0, and we have one more network here too, but we have already configured this as default route, so we don't have to touch this part. Okay, we have already configured this default route. If we have not configured it to default route, we have to configure that also. For example, if it is like 3.0, we have to configure that also. Okay, so for as of now, we have only two routes. So it is network, command is network 192.168.1.0, that is the command. Okay, 192.168.1.0, which is directly connected, no subnet mask, nothing, just input enter. Okay, so we have configured one. Next one is network 192.168.2.0. okay, let's put enter. Okay, so we have configured the other networks also. Okay, so two networks are put into the routing information protocol. Now this information will be actually transmitted to the other routers in the meantime. Okay, as we are speaking, they are actually being transmitted. Okay, next, now configure the LAN port that no routers, configure the LAN port that contains no routers so that it does not send out any information. Okay, now consider this scenario. Actually, what this RIP does is, as I said, the router is going to transmit this information, which means the now I am connected to these networks to the other routers. So there is no point in sending it through a path where there are no routers. For example, consider this network. Okay, now if I'm going to transmit this RIP information to this router, it makes sense. Why? Because there are routers on this path. But does it make any sense to send the information again to this interface? Okay, now this interface is a waste of bandwidth if I send the information also, because there are no routers there and there are no routers to actually get my information to update its routing table. So it is a waste of bandwidth. Okay, and this is actually worth. Now why it is worth? Because to reach the internet, it has to pass through other routers also. So we have to configure, we have to send the information through that path also. So we can make this interface as passive. Now this interface can be made passive so that the RIP information does not go through that interface. No, we don't want to waste that bandwidth. Okay, for that I can actually disable that interface. Okay, so command to disable that interface or make that interface. No, we are not disabling that interface. Disabling the interface technically means we are bringing it down. Now that is different, but we are making it passive. So to make that passive, so you have to type this passive interface. Okay, passive interface and the interface number. So the interface number is G0/0. So you have to type G0/0. Okay, so this is your passive interface. Okay, so we have made one interface as passive and the other interfaces are active actually, so we don't have to do that for other interfaces. Okay, now there is a command to make all the interfaces as passive. We'll see if that comes in the question itself. If not, I'll tell you separately. We will note that afterwards. Now the next point is advertised the default route configured on step 1A with other RIP routers. Now what he is actually saying is we have configured a default route here. Okay, we configure a default route so that the packets that doesn't have any destination or any destination match in the routing table will be sent through the default route. Now that default route must be shared with other routers. Now the sharing is called as advertising here. Okay, we have to tell the other routers also that there is a default route here which will be connecting to the internet. You can make use of this particular route. Okay, so the command to advertise the default route to other routers is, note it down, it is default information originate. Now if you don't actually remember the whole thing, just put a question mark here. If there is something related to that, it will automatically show. Okay, you can see that originate is the missing command here, so it is default information originate. Okay, so we are not expected to know everything and anything by heart. It pays off to know some basics, but mugging up all the commands is practically impossible. If you know the part and parcel of it, if you know just something, you can actually get the other part from the help itself. Okay, so default information originate, so we have advertised the default route message to other routers also, right? So we have completed that step, and then you have to save the configuration. So save the configuration. What is the command to save configuration? Okay, I'll come out of this configuration mode. So it is copy run to start. Okay, so you should not forget this basic command. So destination field start config, yes, so it is copied. So we have configured the R1 part. Okay, we will check afterwards whether we have configured all of them correctly. So we'll come to the next router, configure RIP version 2 on R2. Now enter your RIP protocol mode in R2. So click on R2, click on CLI tab. Okay, enter, enable, configure terminal. Enter the RIP protocol configuration mode is your first step. So router RIP, we have entered. Use version 2 of the RIP protocol. Disable the auto summarization of network. So version 2, no auto summary. Okay, we have done. Configure the RIP networks for directly connected to R2. So we have to configure the directly connected networks to R2. So what are the networks directly connected to R2? We have 2.0, we have 3.0, and we have 4.0. Okay, so remember that we have actually configured R 2.0 already, but actually this was done only for R1, not for R2. So with R2 we have to do it again. Okay, so it doesn't mean that if we have configured for one router it will be applicable for the routers as well. No, it is not. We have to configure the directly connected networks for every individual router. Now then only it can send the information to other routers. Okay, so we will go in the ascending order. So first network is network 192.168.2.0, enter. Again it is network 192.168.3.0, enter. Again it is network 192.168.4.0. so we have configured all the three routes. Okay, so we don't have any other routes, right? Configure the interface that contains no router so that it does not send out any information. Now this is the same thing as your this one. Okay, this one. Okay, so what we did, we actually made them as passive interface. So we'll check what is the interface that doesn't have any router. So this network has a router here, this network also has a router here, but this network doesn't have a router, so that is not wise to send routing information, protocol information to that interface. So I'll make the interface as passive. For that I should know what is the interface. It is G0 bar. I have some difficulty in, okay, it is possibly, okay, we'll check the interface. So do show IP interface brief. Okay, we have G0 bar. Okay, actually G0 bar 10 is configured with an IP address. 0 bar 1 is not unassigned, 0 bar 2 is unassigned, so it must be 0 bar 0. Okay, why I'm doing this, I cannot for sure I can find what is the interface here. There are two things here which are not, as you can see, once again. Okay, I'll zoom it here. Okay, it is actually they two are combined. So I have a certain doubt. If you have a doubt, go to this show IP interface brief. You can see that there are three interfaces: 0 bar 0, 0 bar 1, and 0 bar 2, and serial 0 bar 0, 0 bar 0, 0 bar 0 bar 1. Now you can differentiate between the serial and gigabit by the lines. Okay, so red lines normally indicates your serial interfaces. Okay, and these black lines indicate your G and F interfaces. Okay, so it must be between these three, but in these three only one is configured with an IP address and the status is up, so it must most probably this one. Okay, so I'm going to make the passive interface G0 bar 0. So passive interface G0/0, enter. So we have made the passive interface G0 bar 0, and then save the configuration. So it is copy run to start, run. Sorry, I cannot do this here. I have to come out of this and copy run start. Okay, we have completed for R2, and now we enter the R3. So you have to repeat the entire steps for R2 and R3 itself. So I'll click on R3. I'll do I'll do it fast. Okay, enter, enable, configure terminal. Okay, enter the RIP mode. So it is router RIP version 2, no auto summary. Okay, so we have completed 2 points. And then now we have to configure the networks. Now what are the networks present for R3? We have 4.0 and we have 5.0. We have only two networks. So we will network 192.168.4.0, enter, and then it is 5.0, enter. And the next command is we have to configure interfaces that contains no routers so that it does not send out routing information. So we have to configure the passive interface. So what is the passive interface here? Now this is an active interface because we have a router here. This is not an active interface because this network does not contain a router. So we'll check what is the passive interface here. It is G0/0 again. So we can configure it as passive -interface G0/0, enter. Okay, what was the last step? Now save the configuration. Okay, so copy. Okay, I'll come out and copy, run, start. Okay, we have done for everything. Okay, now we will enter part 2. Part 2 is verifying of configurations. Now view routing tables of R1, R2 and R3. Use the appropriate command to show the routing table of R1. Okay, now we'll check with R1. What is the command? It is show IP route. Okay, so we can see that there are many routes new. Okay, before the configuration we can see that this will only be available CL, CL and CL. Now these are directly connected networks. Now I have explained this clearly in your routing table video and as well as your static routing video. C/L, CL, CL, CL are your directly connected interfaces. Okay, and we have extra these things. So R and this S star. Okay, now this is the default route that we configured. Okay, default route that we configured. Now the first step that we did, default route that we configured through the serial 0/0/1. And what are these? These are the R indicates RIP protocol. So these are dynamically learned protocols through your RIP messages. Okay, and what are the networks that are known? I know the networks 3.0, 4.0, 5.0. Okay, I'll actually show this in the topology. You can see that my router is directly connected to 1.0 and 2.0. I don't know about the networks 3.0, 4.0, 5.0 initially, but after my messages, interchanging of messages between the router, now I know what are the networks available. It is 3.0, it is 4.0 and also my 5.0. All are known here. Okay, now what are the exit interface? It is actually automatically given by the other routers, so it will be incorporated in the routing table. So R1 is done. Okay, so we will study this now. RIP R now appears with connected C and L routes in the routing table. Yes, we saw that. All networks have an entry. You also see a default route listed. Yes, we also saw that. Now view the routing table for R2 and R3. Notice that each router has a full listing of 192.168.x.0. X can be like 1, 2, 3, 4, 5 and a default route. Now I'll go to R2. Okay, again the same command, which is show IP route. Okay, so you can see that we have CL, 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 but also we have learned new routes like R, remote routes through the RIP protocol R. Okay, which is 1.0, 2.0 and 5.0, which are not directly connected, which are remotely connected. And also, now this is important, you can see that it is R star, but in R1 we saw it as S star. Why? Because we configured that in R1 as a static route. Okay, but this star indicates that it is default, but it was learned through RIP protocol. So that's why it is called as R star. Okay, so via the serial 0/0 interface. Okay, so that is how you learn about the default routes through other routers. Okay, now similarly we'll check with R3. Show IP route, enter. Okay, similar configuration here. We have directly connected. Sorry, we have directly connected CL routes and then your RIP routes and default route through RIP. So we have done all the configurations. Okay, now we'll go to the next part. Verify full connectivity to all destinations. Every device should be able to ping every other device into the network. In addition, all devices should be able to ping the web server. So we'll check pinging. We will try from PC1 to web server and then also from PC1 to PC3. Now we should see if each device is interconnect and also it connects to the web server. and then we also check if PC3 connects to web server. Okay, I think 3 checks will be more than enough. So first I'll see what is my first PC1. I'll check desktop command prompt. I'll go to the command prompt and then type ping 64 dot sorry it is 64 dot 100 dot 0 dot 10. Okay, so the first ping might be late because of the ARP. The request may timeout, and from the second ping it should ping, right? So we have done the configuration correctly. Now we will try from PC1 to PC3. For that I should know the IP address of PC3. So IP address of PC3 is 5.10. Okay, so it is ping 192.168.5.10. Enter. Again, because of ARP it might take some time, and request timeout. After that it should come. Yes, it is coming. So we have interconnection between the routers, and finally I'll ping from this PC through the web server. So it is command prompt ping 64.100. Sorry, I made a mistake. 64.100.0.10. Okay, so the reply has come. No, ARP doesn't, it did not apply here, because already there was a communication between PC1 and web server and PC1 to PC3. So somehow the PC learnt about this IP address, so the ARP was not required. Okay, so that's it for dynamic routing table. If you have any doubts, please comment it. We'll sort it out. Thank you.